انشالله که حال شما خوب باشه، انشالله که سلامت باشید. I hope you are well. This is another session of advanced database. Okay, in the previous session I talked about the partitioning, and now I'm going to talk about another challenge of partitioning, another technique partitioning, which is called rebalancing. I apologize that in the previous lecture I did not attend because it's no problem, Mustafa. I hope you are well. No. Okay. In the previous session, I talked about the rebalancing. Rebalancing is one challenge and one important process in when we use partitioning. Okay, so I'm going to talk about some strategies for rebalancing. Alaikum assalam, Umar. In rebalancing, we are going to balance the load between some partitions. Okay, so we are going to assign some data, some load of overloaded partitions to some other partitions which have low loads. There are some strategy for balancing. Okay, we are going to assign partitions to nodes. And we can use hash mode n technique. We can use hash mode n technique. In this technique, the load by using the technique that I'm going to talk about that. For example, when we have okay, I'm going to stop sharing and share whiteboard. For example, when there are some partitions, for example, partition 1, instead of writing partition 1, I'm going to write P1, okay? P1 instead of partition 1. And P2, P3, P4, P5, P6, P7, P8, P9, P10, 11, 12. Okay. The data is divided into 12 partitions, partition 1, 2, partition 12. And when there is, for example, when there is 3 nodes, node 1, node 2, and node 3. We can spread this partition between these nodes. The partition 1 can assign to node 1, partition 2 to node 2, and partition 3 to node 3. Again, partition 4 to node 1, partition 5 to node 3, partition 6 to node, to node 2, and partition 6 to node 3. Partition 7, partition 8, partition 9, and finally partition 10, partition 11, sorry, partition 11, and partition 12. I use the mod function to specify appropriate nodes for each partition. Since there is 3 nodes, by using hash mod 3, by using the mod 3 function, these nodes can assign to each partition. Do you agree? Is it clear up to now? Can you understand which method is used to specify the appropriate node for each partition? Okay. Okay. After some time, we can add new nodes to these nodes. For example, the node 4 is added to this set. Okay, so because of high load for some nodes, we decide to add the number of nodes. So we add another matchings. The node 4 is added to this set, node 4. And we know that these partition need to spread between these four nodes. Okay, so again, by using the mode function, instead of using the mode tree, okay, in this state, we need to use mode 4 to specify appropriate node for each partition. So, uh, uh, okay, then the partition 1 again need to assign the node 1, the partition 2 to node 2. Okay, is acceptable. The partition 3 is assigned to node 3, but the partition 4, based on this function, based on this function, the move function, the partition 4 should assign to node 4, not before that the node 1. Okay, so we should to change this partition. Okay, please. Okay, so the partition 4 assigned to node 4. And after that, the partition 5, in the previous state, in the previous situation, the partition 4 is assigned to node 2. But based on this function, based on the mode 4 function, the partition 5 need to assign to the node 1. Again, the partition 6 in the previous state is assigned to node 3, but now I should to assign the node the partition 6 to the node 2. Again, the partition 7 should assign to node 3, and the partition 8 assigned to node 4. Again, the partition 10. The partition 9 need to assign the node 1, but in the previous state, the partition 9 is assigned to node 3. Okay, so when we use this function, the mode function, okay, so by adding new nodes or adding new function, or in another state, by omitting or deleting some nodes. For example, we have 5 nodes, and after sometimes the node 5 is disconnected from the network. Okay, so one node is reduced in this network, in this state. So again, all partition need to change its situation and go to another node according to by using this function, by using the mode function, and it's not appropriate because we need to change many records, many data between some partitions, between some matchings, and it decrease the performance, the system performance, and also yes, it's not appropriate. It's not appropriate method. But ask every 4 parts of the single not are equal. Usually it can be equal, Omar. Nazar, in the case of adding a new resource to the system require redistribution of partition. Yes, Nazar, yes, is it correct? It's right. And this is an extra load and can reduce performance significantly. Mustafa, look, doctor, why we use mode just? Okay, this is one approach, Mustafa, and we can use another methods, but this is one approach. In this approach, we use the mode function, but it's not appropriate. And also, I'm going to introduce some other approaches. Okay, so now we can stop this and come back to slides. Okay. The hash mode n. If the number of nodes change, most of keys will need to be moved from one node to another. We see this state in the figure that I drew there, and we don't use this solution. Another solution, using fixed number of partitions. Create many more partitions that there are nodes. And assign several partitions to each node. Yes, we can assign several partitions to each node. In the case of an added node, a few partitions are moved from every existing node. Okay, in this method, fixed number of partitions. Okay, such as this figure. You can see for nodes, for node 0, node 1, node 2, and node 3. And you can see each node consists of some partitions. Partition 0, partition 4, partition 8, partition 12, and partition 60 are assigned to node 0. Okay, and also you can see some other partitions which are assigned to other nodes. In this technique of fixed number of partitions, the number of partitions is much more than the number of nodes. Okay, so some partitions are assigned to each node. Okay, so when in the case of an added node, okay, for example, in this example, the node 4 is added to the to this set, to number of nodes. Okay, so a few partitions can move from every existing node. You can see since a new node is added to the set of nodes, okay, the number of nodes increase from 3 to 4. In this example, one partition is selected from each node, and this partition is mapped to the other nodes. Okay, so for example, the partition 4 is omitted from the node 0 and is added to the node 4 in node or another example. In the partition 9 is omitted from node 1 and is added to the node 4. Okay, you can see one partition is selected from each node, and these partitions are assigned to the new node, the node 4. Okay, so this is the previous level, the previous step. You can see some nodes before rebalancing and after rebalancing by adding new node. You can see another combining partitions in each node. Is it clear for you? This figure is clear for you? Yes, Nazar, is it correct? Here, we don't redistribute all the partitions, and only one partition is selected from each node. Yes, is it right? So it's easier from the previous one. Yes, it's easier and it's better than previous one. Yes. Mustafa, it is possible to repeat, doctor. Which part, Mustafa? Okay, again, if I want to talk about this slide shortly, I can say there are some partitions. There are some partitions on each node, and in rebalancing technique, only some partition. For example, only one partition is selected from each node, and this partition is mapped to the new node. In this figure, you can see the node 4 is added to the set of nodes, and so you can see only the partition 4. The partition 4 is selected from node 0. The partition 9 is selected from node 1. The partition 14 is selected from node 2. And these partitions are mapped to the new nodes. Okay, is it clear, Mustafa? Is it clear for you or not? Alaikum assalam, Zia. Welcome, Mustafa. Okay. This technique is used in some distributed database, such as React, Elasticsearch, and Couchbase. These databases are used this type of rebalancing. Adding a new node to a class to a database cluster with multiple partitions per node. Some other notation about assigning partition to node and about this technique for each number of partition. We know splitting and merging partition is difficult. Splitting and merging partition is difficult. So the number of partitions should accommodate future growth. And when we want to define the number of partitions for each database, we must consider that this database wants to grow over some times or some years. Okay, so at the first stage, initially, we should talk about the number of partitions, think about the number of partitions. Okay, so don't forget that splitting and merging partition is difficult. So initially, please consider about the number of partitions and choose appropriate partitions. The best performance is achieved when the size of partition is just right. It's just right. Okay. Okay. Another technique, another approach for rebalancing is dynamic partitions. Okay, in the previous time, we saw the fixed number of partitions. The number of partitions was fixed. Yes, for example, in this example, the number of partitions is 20, and from partition 0 to partition 90. Okay. Before rebalancing, the number of nodes are 4, and 5 partitions are assigned to each node. But after rebalancing, again, the number of partitions is 20, and the number of partitions is fixed again. We don't want to, in this technique, we don't want to change the number of partitions, and this is the fixed number of partitions. So after rebalancing, the number of partitions on each node is changed. Okay, from 5 partitions on each node. Okay, so at this stage, after rebalancing, and there are four partitions on each nodes. But in the previous one, before rebalancing, there are 5 partitions on each node. Okay, so by rebalancing, we are going to decrease, to reduce the loads on each node. Okay, another technique for okay, I talk about the fixed number of partitions. Is it clear? Okay, NASA is okay. Another technique is using dynamic partitioning. Okay, so in this technique, the number of partitions can change over time. The number of partitions can increase, can decrease, and don't forget in this technique we need to splitting and merging partition, and it's difficult. HBase and routing DB create partition dynamically. HBase and routing databases create partitions dynamically. Okay, they can split or merge the partition. The default value for HBase is 10 gigabyte. Okay, when the number of partition is more than 10 gigabyte, the HBase and divide the HBase increase the number of partition. For example, when the number of partition is 1, when the size of data is more than 10 gigabyte, okay, HBase split the data into 2 partitions. Again, when the number of the size of data is more than 20 gigabyte, again it must increase the number of partitions. So don't forget that HBase and routing DB create partition dynamically. It's not easy, it's difficult, but it's a technique that is used by some databases. It requires pre-splitting. Okay. A fixed must choose neither too big nor too much small. Yes, Mustafa, but it can close to the small, but it's better to far from the big size. It can close to a small. Assigning partition to nodes. Okay, how we can assign, which function and procedure are used for assigning partition to nodes. Partitioning proportionally to nodes. The number of partitions is proportional. Yes, the number of partitions is proportional to the size of database. And some fixed between the minimum and maximum. Mustafa talk about these. Some fixed size between the minimum and maximum. Okay, so we know that the number of partitions is proportional to the size of database. Big database need to split to the more partitions in comparison with the small databases. Cancel row and Cat will make the number of partitions proportional to the number of nodes. Some databases specify the number of partitions proportional to the number of nodes instead of the size of data sets. Okay, when there are small nodes, okay, so the small partitions can be used when the number of nodes is not too is small. Okay, since a large data since a larger data value generally require a larger since a larger data volume generally require a larger number of nodes to store. This approach also keeps the size of each partition fairly stable. Okay, again, since a larger data volume generally require a larger number of nodes, so this approach also keeps the size of each partition fairly stable. Okay. The rebalancing technique can be done automatic or manually. What's the difference between the automatic and manual rebalancing? In automatic rebalancing, the procedure is responsible, the function is responsible to decide about the rebalancing and when, at which time is appropriate for rebalancing in automatic rebalancing. But in manual state, there is one administrator or one administrator or DBA that decide about the rebalancing. And okay, the administrator need to check the load of nodes and the load of matchings. When there is some overload matching, okay, it can decide about the rebalancing. I can say the manual rebalancing can be appropriate, can be better than automatic rebalancing because the automatic rebalancing is unpredictable, and it can be dangerous with automatic failure detection. So the manual rebalancing can be better than automatic rebalancing because sometimes because of some situation which can occur for any network. For example, in sometimes one node of network can be can disconnect from the network. The connection between the one nodes or some nodes from other nodes can cut off from sometimes. Okay, so in this same in automatic rebalancing, the procedure can think that the load of nodes is heavy. Okay, so sometimes it in this state the software or the procedure can decide that rebalancing and move some loads from the overloaded matching to the another matchings. But it can be dangerous because the nodes can turn back to the network after some times. So it's better that don't decide in this situation, and we can wait for some times, and after some times, we can decide about the rebalancing. Okay, partition assignment can be suggested by record administrator to commit. So partition assignment. In manual rebalancing, partition assignment can be suggested by require, but require an administrator to commit. It's better. A combination of automatic and manual rebalancing. The partition assignment can be suggested by software, but the administrator should commit. It's better because the administrator can talk about observe the situation, the nodes, and something which is happened for the network, for the database, and it can decide about this situation. Is it clear for you? Is clear for you the difference between the automatic and manual rebalancing? What does this mean? Because Omar, this is brief because okay, I'm going to say one example. One node is the connection between one node and the other node is cut off temporary, Omar, okay? The software decide that rebalance rebalance the partitions and okay, because it thinks that one node is omitted from the network and we have not this node for sometimes, okay, so the load spread between the load which belong to this node spread between other nodes. What I say you is temporary, and the node which is omitted from the network come back, and after some minutes, okay, after sometimes, and again the node is come back, and now again the load should spread between again some okay, I'm going to yes, Nazar, yes, your sentence is right. It's surely your sentence is correct. It's better to get an automatic rebalancing with a supervision manual. I say you that, for example, there are 5 nodes, and the connection between one node and others is disconnected temporarily. For example, between this node, the connection between this node and other nodes is cut off temporarily. Is cutting off temporarily, and okay, the load. The load are assigned between these 4 nodes, and after some time, again, this node, which is this node can come back to the network, and again, there is a need to move the load from other partition to this partition. It's an extra load that are moved from some partitions. So again, the administrator should decide about this committing rebalancing or not. Okay, is it clear for you, Omar and other Mustafa? Okay, require human to prevent surprises. Yes, Mustafa. Yes. Thank you. Thank you for helping me. Another topic that I'm going to talk about that is request routing. Request routing. In partitioning, the partitions are spread between some nodes, and okay, when we are going to send a write query for a specific record, okay, and this request for a specific key need to route to appropriate partitions, to appropriate matches. Okay, so we need this component, this module, request routing. The request routing receive the request and is responsible to find appropriate partition and matching for each request. The service discovery is appropriate sandwich which are used for this request. The service discovery is a general topic in distributed systems, and is a common module and component which is used in distributed systems, and also we need this component in distributed database. A requirement is high availability. Requirements in high availability. Okay, so I'm going to talk about some technique which can be used for request routing. We need the knowledge of which partition is assigned to which node. Yes, which partition is assigned to which node. For example, in this slide, for example, you can see the partition 0, the partition A, the partition 12, 16 are assigned to node 0. And some other partition are assigned to node 1. We need to know the knowledge of which partition is assigned to which node. Okay, so this knowledge can be stored in all nodes. This knowledge can be stored in all nodes. Okay, so for example, when the client wants to get full, this request can be sent to each node. Can be sent to each node. It's not different because all nodes have the knowledge of which partition is assigned to which node. All nodes have this information, this knowledge. And so, for example, when this request is sent from the client to the node 0, okay, so the node 0 know that for example, the food is stored in the node 2, so the node 0 send this request for the node 2, and node 2 can reply appropriate information, appropriate data for the client. Okay, is it clear for you? Is it clear? Nazar wrote that each node contain a location of any piece of data to be stored. Yes, Nazar. Thank you. Okay, in another technique, there is a routing tire. There is a routing tire. The routing tire consists of the knowledge of which partition is assigned to which node. And so all requests from all clients should send to routing tire, and routing tire decide about the request. For example, in this figure, you can see the routing tire. Now the food is stored in node 2. So this request is sent to the node 2. So again, in the this side, in this method, there is a routing tire. Okay, and finally, in another method, each client has the knowledge of which partition is assigned to which node. This information can store to all clients, and so the client can use the information that are stored in its own matching, and okay, it can find appropriate matching without using another matching, another component. And okay, so the client knows that the full data is stored in node 2. Okay, so this request is sent directly to the node 2. Routing tire is node or what? Yes, the routing tire, it can be appropriate matching, which is responsible to find appropriate nodes for each request. Yes, Nasa. But also in the tree, you can see that the routing tire can be a part of the part of each matching, the part of clients matchings. But when the load when we need load rebalancing, and when the number of partition wants to change over time, okay, this technique is not appropriate, because each piece of data can move from one matching to another matching, and this information should send to all clients. This technique is not appropriate, especially when there is a significant change in moving partition between some matches. So we prefer to use one matching, and all information can store to one node. Okay, I'm going to talk about this slide more than this. But before that, you can rest for some times. Okay, I suggest you to rest for 5 minutes. After that, inshallah, I'm going to continue speaking about this slide. Okay, we can have a break time for some times. After that, inshallah, I'm going to talk to continue discussing. Okay, we can continue this concept after some time, some break time. Okay, I talk about this slide. I say you that there are two different types. There are three types. In the number of clients is very, very more than the number of matches in which the data, uh, which are used to store the data. Okay, so in the type 1 and the type 3, you can see that the knowledge of which partition is assigned to which node are stored to some matches. In type 1, this information, this knowledge, is stored in all nodes, and in type 3, this information, this knowledge, are stored in all clients. Okay, so both type 1 and type 3 is utilize the distributed method to store the knowledge. But in the type 2, you can see only one node, which consists of the information, the knowledge of the partitions and nodes. And and this is a centralized method. This is a centralized node. The centralized method can cause some problems. For example, when the connection between the routing tier, between this node and the client and some matches, this connection can cut off temporarily. Yes, it can cut off temporarily. Okay, so when the connection between the routing tier and nodes is cut off, what happened? So this technique can cause some problem when we use centralized techniques. Why we use a distributed database? Because we don't want to store all nodes on one machine. So again, this technique using only one node for routing to store routing tier as routing tier to store the knowledge. Okay, it cannot be appropriate because it's possible that in each time the connection between the routing tier and the client or the nodes can cut off temporarily. So we prefer to use some matches which have the information of the partition and nodes. So the type 1 and type 3 utilize the distributed technology, distributed method. But also, again, in comparison between the type 3 and the type 1, we can say that the information and all information need to in type 3. All information need to assort to all clients. The number of clients is very much, and in this technique, okay, we need to store this knowledge on all clients, and okay, again, you can see it can it's not appropriate, it's not proper method because each client need to have appropriate memory, and the client need to get the knowledge of all of the knowledge of the partitions and the nodes, and okay, so you can see that each type has its own advantage and disadvantage. For example, the advantage of the type tree. What is the advantage of type tree? In type tree, the client can find the appropriate node sooner, more in comparison with. Oh, please let me. Yes, in the type tree, the client can find appropriate node in a shorter time in comparison with other two types. Yes, but also we know that in the type tree, and all the knowledge should soar to all clients, and okay, so there is uh, lots of much space, much memory, much size of memory should use to store the all knowledge. In 3, Nazar wrote that updating the data require updating the information stored in each user. Yes, Nazar, yes. So when there is a when there is a big change in data, okay, so it's an extra load for each client. And in 3, it's easier and faster to get the data. Yes, Nazar, thank you. How does the component making the routing decision? The component, Mustafa, consists of the knowledge. So it can use the knowledge about the partitions to get decision. It's not difficult because this knowledge is clear. This knowledge is clear for the matching, and it's not difficult. Okay, about the protocol, yes, Mustafa. If it means that you want to, which of these types is used for request routing, it's up to the software, it's up to the database, and yes, it's up to the protocol which are implemented on each database. There are differences between the databases. Some of the databases prefer to use the type 1, sometimes prefer to use type 2, another type 3. But the protocols are specified, and there are different between and is up to the implementation. For example, the zookeeper is very the zookeeper is a well-known component for request routing. The zookeeper consists of the information, consists of the knowledge of which partition is assigned to which node. The zookeeper can be the part of root entire. You can see this consists of some information. For example, the key range between some values are stored in which partition. For example, partition 0 or node 1. Okay, this information are stored in the zookeeper. Please see the figure. Please pay attention to the figure. You can see in each category of data, for each category of data, it is specified that these data are stored in which partition and in which node. And this is the IP address of the node. Okay, you can see 12 partitions, and these 12 partitions spread between 3 nodes, node 0, node 1, and node 2. And also you can see the IP address of each node. For example, the node 0, the IP address is 100, the node 1 is 101, and the node 2 is 102. They are repeated in the following. Yes, this is a technique, this is component which is used to keep track of assignment of partition to nodes. Yes, you can see that when the client wants to get one data, this request is sent to the root entire, and root entire use the knowledge which is stored in zookeeper, and okay, it's find appropriate node. Yes, this is the final slide of the partitioning of this course and this concept. Is it clear for you what is the zookeeper and which is its responsibility? Okay, yes, its responsibility is to find the appropriate nodes. You know, this type of the zookeeper is used in type 3, yes. This technique, this component is used in type 3. And I say you that it's so well known and famous in routing request. Okay, that's enough for today. If you have any question, okay, I'm going to listen and inshallah answer your question. If you don't have question, we can finish the class now, and inshallah in the next session I'm going to continue this concept. You're welcome, and thank you so much for helping me, and thank you. If you don't have any question, we can finish the class. Okay, so goodbye. Have a good time. Have a good day, inshallah, and bye for now. Thank you so much. Bye. خدا حافظ شما انشالله بچه. خدا حافظ شما. You're welcome, Umar. You're welcome.